Welcome to Gradation 101. Today we're just going to do a smaller sample size. This video is for just using the Marianne, this green shaker that's in the background. We'll do a different video in the future with the Gilson. That's the big one, big blue one with the big screens. It's the same principles, but it's a little different process. So we'll use this Marianne shaker, the smaller one with the smaller sieves. This is for a smaller rock size, usually road base and smaller, 1 inch minus and smaller. When you have bigger rocks, you can't really get that in there. That's when you use the other one. So this is strictly for a smaller sample size with smaller rocks. First of all, and we'll add this to a video later, but first of all, we want to grab the sample the right way. So we want to either use the sample taker if we're grabbing a bell sample. And the big things there are making sure we're getting the full stream. We need to make sure that sample taker is going directly in the stream. Sometimes I've seen where it gets set too far back and you're not grabbing the full stream, so you're maybe missing the fines or maybe missing the rock and it's not a full sample size. So we want to grab that full stream. We want to grab it when the plant is full and running. Otherwise, maybe you're just grabbing straight rock or straight fines. You want to make sure that cone's full, the plant's running at full capacity. So ask your supervisor, whoever's running the plant, make sure it's full at the time. And then you can just run it across quickly, one swipe, wait 5 minutes, and then do that again, get a second swipe. So we're getting 2 buckets to mix together. The purpose of that is that one swipe, we're just getting it's a 1 second shot in time, and so we want to do it. So you're getting a different loader bucket full of material each time, and then we mix it together. We want to get it as representative of the sample as we can from the pile. The other one is the stockpile sample. You want to go in the side on the windrows, on the side of the windrows, and just go in the same area, grab out 5 buckets, set those to the side because those are going to be super rocky where the rocks roll down. Then that 6th bucket, go in, grab it, lay it down flat in a pad, and then we can grab a sample from there, looking again for representative variance. Don't grab straight rock or straight fines. They say to do it like a file on a dice. You do it 1 in each corner and then 1 scoop from the middle. You can take that in and do a sample as well. So I've grabbed one already. The plant that we're at right now is not running, nor do they have a belt sample taker, so I just grabbed a bucket right now. You'll have 2 buckets to split together when you do it. But that's the first thing we do is we bring our bucket in and we take it to the splitter to split it up. The purpose, you look in here, the purpose of a splitter is to separate the material and mix it up a bit so that all the rock's not going one way and the dirt another way. This will split it up different directions and make it a good mix of the sample. And then we're going to keep splitting it down until we get about 2,000 grams. We're going to shoot for a 2,000 gram sample on just this Marianne shaker. So I'll grab the bucket. Make sure everything's out of the bucket, that everything comes out. Split it even, make sure it's even, and then just start splitting it down. And that's going to be too much. It's more than 2,000 grams, so we'll just keep doing that. Try to wipe it all in there if anything gets hung up. that's probably close. It doesn't need to be exactly 2,000 grams. If you're within 500 grams or so, you should be good. From there, we're going to take it over to the scale. When I look at the scale, I make sure it's not touching anything. If it's sitting up against the wall, you can throw the weight off. We want to make sure it's even. They have legs on the bottom that are adjustable to try to make it even. You don't want it bouncing around on here. And then hopefully you can see this in this dirty mess, but it's at 0 right now with nothing on it. And we want to put on our bowl to dump our sample in and collect it. The weight goes up, but we want the weight to be 0 with the bowl on it. And so all these scales have a 0 button or a tear button. But if we push that, it'll 0 it out with the bucket on there. So then we can take our sample, add it to the bowl, and we're at 2407 grams, so we're good. That's a good sample size. I did fail to mention, if you have too much on this sample, if we had 3,500 grams, we can take it back and split it down one more time. If we had too few grams, we can take the rest of the sample and split it down to add what we need. But we don't want to just grab a handful of material. Say we're, I don't know, a couple hundred grams short. You don't want to just grab a handful and throw it in, because that's not going to be representative. We want to keep putting in that splitter, splitting it to get what we need. So now we got what we need here. We need to dry this, and it may look dry, but we still need to dry it just to make sure it's dry, because there's usually some moisture in there, and that's going to make all the difference in our sample. We need to find the true weight of our sample. This amount of rock and dirt can change weight quite a bit depending on how much it's rained or snowed, or if it's a dry day. It's the same material, but that moisture is going to make a big difference. So we need to find the true weight of the sample. So we're going to put it in a clean container. We're going to put it on the burner. And just start cooking it. And the flame can be pretty big. We can cook this pretty quick. It doesn't have much moisture in it, so we can cook it as hot and as quick as we can. You'll be able to see this stuff's pretty dry. We probably won't dry it very long, but you should be able to see the moisture coming out of the rock. You'll see it get wet, and then that moisture leave the rock, and visually you'll be able to tell if it is dry or not. So now our sample's dry, and we got our weight. It might be a little hot still, but we put it back in the bowl. We want to make sure, again, it's reading 0 when we put it on. And this is important to get the true weight. So now we know our true weight is 2406 grams. It's going to bounce a little bit because we're not in a lab setting where everything's stabilized. We're in a van that moves here and there, and so it'll bounce a little bit. Just try to get as close as you can to the right value. It's important to write this number down right now before we forget it, because this is probably the most important number on here. So the weight after drying it is 2,406 grams. And we can leave that for now. It might be a little warm still. So we're going to put it back in this container. And most of your vans will have some sort of fan system, and that's going to help suck that heat out and get it outside, because we just want to be able to cool it as quick as we can. If we don't cool it, when we add water to it next, it starts throwing dirt and rocks in the air, so we're going to cool it. We'll throw it up here in our makeshift table. turn the fan on. If you do that for about 10 minutes, you should be good. I'm skipping that right now because we let it dry already. So next we're going to wash it. The purpose of washing it is to get out all the what's called 200s that we can. It's the super fine dust. It's the, I don't know, I've heard people call it bug dust or moon dust on site that gets kicked around. It's everywhere and on everything, and so it sticks to rock like crazy, and so we're going to try to wash out as much as we can, just so it's not sticking to any rock, because even going through the shaker, it still can stick to it quite a bit. We'll get rid of a lot of it, but not all of it. So again, every van's a little bit different on how they have their pump set up and their sink set up. This one's high pressure. If I shot that right into the dirt, it would just blast everywhere. So I'm going to put a rag over this one just to slow the flow and start washing it. So we don't want to lose any of the sample. It's important all the sample stays in here, so we're not going to blast any of it out of there. And we're going to wash it into this 200 sieve because we don't want to lose anything that's bigger than 200. As a quick note on sieve size, you'll see that we've got ones that are labeled as 1 inch or 3/4, and it makes sense there. And then we start getting down to numbers. It's number 4, number 16. This is number 200. You can see it on the side of each one. But those numbers mean how many holes there are per square inch. So number 4 has got 4 holes. Number 200, you can't really see the holes. There's 200 holes per square inch. So we want to keep everything that's bigger than that and get rid of everything that's smaller. So we're going to agitate it by hand, and you'll see that it can dirty up the water. We're just trying to get rid of dirty stuff. If you pour it in too quick, it can splash everywhere. So we're going to try to go keep it close and not go too quick so it doesn't splash things out of it. We want to be gentle with it because, again, this 200 sieve, it's not as sturdy as the bigger metal ones, and so if you're dropping big rocks on it, it's going to dent it and damage it. So we just want to be gentle with it. So we're going to try to not let any of the big stuff fall out onto it. We just want dirt hitting it. And then we're going to wash it 4 or 5 times until the water gets more clear and we can wash out as many fines as we can. getting much clearer. We've washed out as much as we're gonna get right here in this setting. And you can tell there's still some stuff sitting on this sieve. You can see in the sink, there is stuff passing the 200 that washed out. But there's still stuff left over, so we need to get this stuff back to our sample so we can test that properly. And so we're just gonna wash it back in. Which adds more water to our sample. If we need to get this dry again so that it's not gonna plug up the sieves when we put it through the shaker. And if we just threw it on the cooker like this, it would take one, forever, because you've got this stew going now with all this water. But two, the more water you have, as it heats up, the more it wants to pop, and it starts throwing rocks out and mud out, all stuff that we need in our sample to know what our sample really looks like. So we're gonna pull out as much water as we can with the turkey baster, and we just wanna keep this at the top so that we're not sucking up any rocks or dirt down at the bottom. And just get out as much water as you can. That's the only purpose of this, is just to speed up and better the process when we're cooking this and drying it back out. All right. As you can see, most of the water's out now, but it's still a sludge. We need to get this dry so that it can go through the shaker. It's the same concept as the screens, as you guys have probably seen in the winter or rainy. If you throw a big bowl of mud in or a big bucket of mud in the screens, it's going to plug everything up. It's the same thing with this stuff, just on a smaller level. So we're going to cook it, and this time we don't want a big flame. We want a very small flame. We're going to cook it low and slow, and we're just going to leave it for a while like that. The other one didn't have much moisture, so we could cook it a lot higher, but now that we've got a ton of moisture in it from washing it, we want to cook it low. When we turn that heat up, again, it starts throwing mud and rocks everywhere. And so we're just going to put it on low, and we're going to leave it for a little while. We might be inclined to start moving it around already with our spatula, but we don't want to do that when it's very wet, because it's just going to make a giant mud ball. It's all going to stick together, and then it doesn't shake down. So we'll leave it, just keep an eye on it. It'll probably take 10 minutes or so to really start drying. When a lot of moisture is out of it, you'll be able to see it, and then you can start moving it around some. All right, now we'll move it around. We can see that it's all dry. Now it's time to get ready to shake it out and see what it is, how it lays out in each sieve. But first, it is scorching hot right now. The hot rock's not going to do us any favors, especially like I was showing that 200 sieve. Like, the hot rock is going to melt that down and ruin that sieve. So we want to cool this down until everything's at room temperature is the next big thing to do. If we put it in too quick, those smaller end sieves are just going to melt, and it's all going to get ruined. So make sure you got your gloves, because it is hot. And we take it back to the fan, and we're going to cool it for another 10 minutes or so. And after that, we'll be able to throw it in the shaker and see how it shakes out. All right, it is cooled down enough that we can run it. Let me just take the whole sample and dump it right in the sieves. The sieve sizes you'll need will be based on each job. Each job, the spec will call for different sieve sizes. So we'll make sure we have those ones in there. You can add more sieve sizes just to alleviate some of the burden on certain sieves. For instance, I always put a number 100 sieve on there just to alleviate some of that burden on the 200 sieve, since it is so fine. But definitely the ones that we do need is whatever the spec is. We dump it all in, and you'll see that as we dried it, it's dried some stuff to the bottom that is part of the sample still. We need to get that in there. So Grab a wire brush. Once it's all in, put the lid on. We'll put it in the Marianne. This does adjust and rotate. We want it leaning back when it's shaking so that the rock flips around more. We have some different models of the Marianne. I mean, they all look the same. They're all a green box. This one, none of this is working up here currently, but on most of them, it'll have a 10-minute timer that if we turn it on, it'll just be 10 minutes. This one isn't working that way right now, so we'll put our own timer on for 10 minutes and let it shake. It's done shaking and we're ready to start weighing. I'm going to check the scale again. We got this on here, it says 1 gram, so I'm going to just make sure it's back to 0. Pull out the sieves. Start weighing. Usually on this one specifically, it's supposed to be all smaller than 1 inch. I usually put the inch screen on there just to make sure we don't have any broken screens outside. There should never be anything on the top screen we're using. That's just there to make sure we're small as we need to be. For this one, the next screen is a 1/2 inch. And we're just going to add the rock. Some rocks will get stuck. Gently hammer them out. We don't want to hammer them too hard or we can ruin the screens. But pay attention too, because sometimes they can ricochet out and go somewhere. So don't get too carried away. So now we've got the weight of everything that was retained on our 1/2 inch. It's 1009.5. We're going to start writing that down on our paperwork. So that first screen was 1 inch. We retained 0 grams on it. And then 1009.5. And it's cumulative. If you read that, we're just adding the weight as we go. We're not taking anything out. We're adding each time. I'll take the next sieve. A 3/8 sieve. 3/8 is our next number on our list here. So we're going to write that in there. If you don't have a big bowl like this, I found that finding a big tote can help, just so that the rocks all are going to the right place and not falling out. The number 4 sieve. And you'll notice as they get smaller, there's more rocks that get stuck. And this hammer's probably become too big. So we can just start scraping them out with our spatula. Go back in. This is our number 4 number. Next is a 16. And once it gets past that number 4, don't hammer any of the screens. You're just going to damage them. We'll just scrape. And then you'll notice on my paperwork, we only want to know the number 200 is left. But you'll see we've got 2 screens left. Like I said, I added this 100 sieve just to alleviate the 200 sieve. But they only care what's retained on the 200. So I'm not going to throw this away. This is still part of the sample. But I'm going to add it together as if it was all retained on that 200 that they're asking for. $22.96 is our final. We've got some left in the pan. We're not going to add that in because everything left, everything that we washed out, everything in the pan is accounted for in our dry weight. When we took that dry weight in the beginning, that's our total sample size. So everything's accounted for there. And now we're just going to get out our calculator and do some math. Each sieve number, each weight retained number, we're going to divide by the total weight. So the first one, we do 0 divided by 2406 is naturally going to be 0% retained, which means 100% of the sample was passing. These two numbers, or these two columns together, need to equal 100%. Since we're 0 retained, 100% was passing. On the half inch, we do 1009.5 divided by 2406. And if you look here, it just gives you a decimal. We slide the decimal over 2 numbers to get our percentage passing. So it would be 41.95. Since that's 0.95, we'll round it up. We'll round this 9 up to 0, so it's 42. We just want to round to 1 decimal. So since this is 42 was retained on it, 100 minus 42 is 58. So we'll say 58% is passing. We do 1208.5 divided by 2406. So again, slide it over to 50.2. 100 minus 50.2 is 49.8. 1593.5 divided by 2406. Slide it over 2 spots and it's 66.2. 100 minus 66.2 is 33.8. 1986 divided by 2406. 82.5. 100 minus 82.5 is 17.5. And then 2296 divided by 2406 is 95.4. 100 minus 95.4 is 4.6. So on yours, if it's a spec product that they're looking for spec, we're going to write the spec down here. So say this was, I'm making one up, but you'll know what it is on each job. We'll say this one is 100. We'll say this is 60 to 90. Maybe this is 30 to 60. 20 to 40. 10 to 30. 0 to 10. So we write the spec that they're looking for there, and then we're checking. So it's supposed to be 100% passing. That one's good. If it was 60 to 90, well, we're a little out here, so we're not quite good there. 30 to 60, we're in there. 20 to 40, we're in there. 17 is in there. 0 to 10, it's in there. So at this point, it's important that we take our sample to whoever's running the plant and show them our results as they are. And we say, hey, we've got a little too much retained on that ½ inch. We need to get a little bit dirtier, I guess, and that's where we start making adjustments. But the quicker we can run samples and get more information to whoever's running the plant, the better we're going to be. If the sample's out, it's not anything other than a data point. We need to know if it's out so that we can adjust as we go. And then as always, give a call if you have questions. But that should wrap up just the Mary Ann session. We'll put another video together with the Gilson shaker. Thanks, guys.